And we are back already. And we are going to bring in our new speaker, who is no one. So it is Vedant, who I'm going to call in. Hi, Vedant. How are you?
Hi.
Hi, I'm doing good, and it's so good to be here. Hybrid.
Yes, great that you are here. So can you introduce yourself before we start with your session?
Sure, I'm Vedant. I am joining in from Vancouver here in Canada. I'm a Gold Microsoft Learn Student Ambassador, and I'm excited. I've been working on Microsoft technology for quite a while and just continuing with the same, sharing the same here, and excited to be here.
Oh, wow. You also have a great session title. You're going to find
Mhm.
Dory.
Yes. So Dory is my fish, and she's lost in somewhere in the ocean, and that's the agenda. Let's find her.
Oh, yeah. Let's go. Let's go and find her. Good luck.
Awesome. I'll start by sharing my screen. Just a minute. All right. I hope you can see my screen. Awesome.
Yes, we can see it. Yeah.
So finding Dory. And so this is a mission, right? Let's take it as a mission. And I'm your mission commander. So hi there, Vedant. As I said, I'm joining in from Vancouver. I'm a student at University of British Columbia. I'm also a Gold Microsoft Student Ambassador. And I've written a couple of books. I'm also author and a TEDx speaker. So are you ready for the mission? We'll respond with I in the chat, and let's go with that. So what's the mission pre-story? Like before getting to the mission, let's know what's the story around. So Dory is my fish, the blue fish over there on the screen. And she was playing with one of her friend, Marlin. They were playing in the deep ocean, they were having fun. But unfortunately, I don't know what happened because I wasn't there, but even Marlin doesn't know what happened. Dory got lost. Now, what do we do about it? So, one approach was to just look for Dory all around, but that's difficult because I'm not that great in scuba diving, and also I've got classes to do here at UBC, so really cannot afford a lot of time. So I got Cami. Cami is another fish who is a photographer, and Cami loves clicking photos all around the ocean and stuff. So I asked Cami, why don't you just go across the ocean and take photos of random places and send it to me? Maybe I can go through all these photos and look for Dory and probably can find Dory somewhere in those photos and then can go there and get her back. Now that's one of the approach. But there's a problem with that approach. The problem is that how many photos can I scan through manually? Although Cami is sending me photo, that is amazing, but how many photos can I manually scan through and uh, look for Dory? Now that's the issue, and that issue can be solved using something called computer vision. Now, I don't want to assume that all the audience here, all the viewers here knows about computer vision. So we have some kind of mission training here where we'll quickly, like briefly, know about what's computer vision. So computer vision is something which is inside machine learning. Machine learning is something which is inside artificial intelligence. So let's start from there. So AI is just intelligence demonstrated by machine. So intelligence which is artificial, pretty clear by the name. One of the way to achieve AI is machine learning. Now, AI is like broad umbrella, which has a lot of terms and a lot of concepts within that. And one of the way to achieve that concept is machine learning, which is a branch of AI, which focuses on building application that can learn from data and improve their accuracy over time. So basically a branch of AI where we design certain models that learn from data that we hold, any kind of data, and can make predictions or do something with that data. Let's not even call it prediction, but can do something meaningful from that data, and it improves over time, which is called machine learning. And one of the field of AI and machine learning is computer vision, which basically means giving computer a vision. A computer can see and make judgment based on what it sees. So computer vision is a field of AI that works on enabling computer to see, identify, and process image in the same way how humans does. So computer can see, identify, process images or video, everything that it can see the same way how we do it. Now, if you want to know more about it, you can explore that link with computer vision through Microsoft Docs on Microsoft Learn. But this should be enough for what we are seeing right in the future in these slides. So a little more about computer vision. For example, the ball and apple example over here. If you have a baby, a new toddler, a newborn baby, and you have two objects, ball and apple. Now, obviously, you don't want your baby to eat ball and want your baby to eat apple. But those two objects look very similar. They're red, they're around, like close to round shape. Not exactly, maybe, but close to round shape, like a sphere. And obviously, you don't want your baby to eat a ball, but you want your baby to eat an apple. So you're explaining your baby, hey baby, this is ball, this is apple, this is ball, this is apple, this is ball, this is apple. If you say it just once, maybe the baby is not getting it, right? Because you just tell it once, this is ball and this is apple. The intelligence of that person, that baby, is not enough to understand the concept just at one. Maybe it's not able to distinguish. But if you do that every day or frequently or once in a while, but then even in once you do it a lot of times, more frequently, ball, apple, probably after some time the baby starts understanding it, right? That's the same thing that we're gonna do with making the computer understand how Dory looks. So we'll tell computer, this is how Dory looks, this is how Dory looks, this is how Dory looks, this is how Dory looks. And probably the best approach to go about that is not just having one picture of Dory, like just one ball or one apple, but different variations of those things, right? A ball might look like might not look like the same way on how it is shown on the screen, but can be a little different. An apple can be a little different in shape, maybe without leaf, or a half cut apple, or maybe with slightly different color, and so on. So when you show the baby all the variation, all the possible variations, probably they're able to understand better to distinguish between those two objects. So that's what we are planning to do here. We'll, in the similar way, we'll train the computer. So our objective is to create a computer vision model to spot Dory. So we have images that Cami is sending, like Dory's photo. So Cami has sent all those images, and I have those images on this link. So you can, if you want to parallelly do this or do this later on, you can use this link to find some images of Dory that Cami has sent to us. And we'll use Azure credits to use custom vision. So Azure boy over here is very generous to give us some Azure credits. So you need Azure credit and sign up on custom vision using the same account that you have Azure credits on. It creates a resource for you, and that can directly be used to create this model. So that's the approach. Let's start with the mission. Let's see how this is done. Now, why custom vision is because although we know about computer vision now, and the traditional approach is to code computer vision using Python or any other programming language, but that takes a lot of time. So traditional methods is that you're coding it, so it's a code-based approach. Another thing is traditional approaches require a lot of data. Because when you are training a computer vision model, you need tremendous amount of data to make good predictions. But with custom vision, first thing, it's a no code approach. So basically, you're doing no coding. You can do the same thing, like this amazing thing, without any code. And also, it's based on transfer learning. I won't dive deep into it, but transfer learning basically can do the same job with less data, right? So we are using custom vision for that, for those benefits. So the link is customvision.ai. We'll go on to that. But before that, let's just quickly have a look at the Dory's images that I have here. So these are the images of Dory that I have. Just let me probably just share the link screen again so that I can also show the browser. So you can log on to customvision.ai, make sure you have Azure credits. One of the best way, if you're a student, you can get certain free Azure credit. And and that should help you with okay, sorry. Yes, so going ahead, I've got this model. Sorry for the trouble. Right. So I've got my customvision.ai screen, right, on the website, and I'm already logged into it. So I can create a new project. I can name the project. So let's say Finding Dory at Global AI, right? I can give some description to the project and then select a resource group. Now, resource group is how you link the project to your existing resource group at Microsoft Azure. If you don't have one, you don't have to necessarily go to Azure and create one, but you can create from here. So you can click on Create New, enter the name, select the subscription that you have, the resource group that you want to go for, the kind of service, and so on, right? So I already have a resource group created, that is Dory here. And custom vision offers you two type of approaches. So generally those are the two main applications within computer vision, that is classification and object detection. In classification, it's the same kind of ball and apple approach where you're trying to distinguish between ball and apple. That's classification. But here we are trying to do object detection, because we are trying to detect Dory within certain images. So that's object detection, not classification. And within classification, you have, just we can go through it quickly, that you have two options, that is multi-label and multi-class. Multi-class is basically single tag per option, like per image, like there is ball and there is apple. But you can have multi-label, like if there is, within apple, you have, say, uh, green apple and red apple. So you're also tagging apple, you're also detecting apple, but you're also within that detecting the color of apple. So that is multi-label. Now here we have multi-class and so on. So we'll go for object detection because that's our purpose here. I can select the domain. I'll go for the general domain, like because it's general and compact. You can know more about it. Generally, the compact domains are the one which you can use to compact, as you can read here, compact domains are lightweight models that can be exported to iOS and Androids and other application for their end use. So I'll just click on create project. It takes a while and creates the project for you. Now, the next thing is to add the images. So we need to add our training data. I can click on add images and upload the images, right? I can say, I can upload all the images at once, but as of now, I'll just go for, say, 4 images here. Upload 4 images. And here, at least you need 15 images per class. So if we are detecting Dory here, we need at least 15 images with Dory in it, because we are training the data, we are annotating the data. So once I've uploaded the images, I can click on the image and tell computer who Dory is. Like, okay, this is the image, but computer wants to know what object do you want to detect within this image. So I can simply drag like this and tag it and say, this is Dory, right? I have to do this for all the images, like 15 times, because we need minimum 15 images and so on. I can, now, for example, in here, this is Dory, right? I'll say Dory. But this one is not Dory, this is Marlin. So if I want to detect Marlin as well, I can say, this is Marlin, right? I can tag it accordingly. Different object in the same image, there are possibilities that you want to detect different images, different objects in the same image, so you can do this. But again, this, now you have to upload at least those many images, like 15 images, so that there are 15 tags for Dory and for Marlin as well. So 15 images per tag. Once I do that, so it has moved to tagged and I have untagged, right? I can click on train. I can select what kind of training I want to go for, like quick training or advanced training, right? With advanced training, it will take a lot of time, but it can train your model in a very, very good way, like with better performance. I can go for quick training and click on train. Now, if I click on train, it will give me error that you cannot train because you don't have 15 images for every tab. Um, but I've already trained the model here because we don't have enough time to actually go through the whole training because it takes a little while. So upload 15 images, go for training, and this is how it will look like. So I have all these tagged images. I clicked on train, I did the quick training, and once I quit the training, I can move to performance. So once the model has trained, this is how it will look like. It will show you the performance of the model, like what is the precision, what is the recall, and what is the mean average precision across all the classes. So you get those details. Now, based on this, you can go back to training, upload more images if you want. If your performance is not good and you want better performance, you can go back here, upload more images, retrain the model, or train it in a better way. Maybe you went for quick training last time, but you can go for advanced training to get better performance. And you can go for many iterations. So all the iterations will be listed here. It's not like your first iteration will be lost. If you go for second iteration, it will come up here on the left-hand side as iteration 2. It will show what kind of model did you go for, like when was it trained, and so on. And you can adjust this, like how much probability, like how much confidence do you want your model to make prediction with. So if you go for probability threshold, if you increase this, you can the performance usually changes. So this is how you can see on the screen the probability threshold. When we change it, the performance usually changes, and you can check out that. You can move the slider and see on various versions of probability threshold what are your performances and so on. And once that is done, you can do quick test. So let's do a quick test here. I'll browse an image of Dory. Let's go for this one and let the model run. So as you can see, the model is detecting Dory over here on the smaller rectangle on the top with 99.9% accuracy, like probability, and below also with 92.7%, of which like most of the part is actually Dory. So it's not a very bad prediction, but this is how the model makes the prediction. We can also try it out on different image where we have Dory and Marlin. So as you can see, this is a very good thing that our model does. So the model was able to, although both the fishes look similar because they are fishes, so they look like a fish, but it was still able to distinguish between Marlin and Dory because Dory is blue in color. So our model was able to distinguish that, and it didn't give us a box across Marlin, but gave us a box across Dory with accuracy of 95.2%. So it does make some good predictions over there, right? Now, once you're satisfied, you have trained the model, you're satisfied with the performance, you're also satisfied when you tested the model on certain images that you had, you can go ahead and publish this model. So I've already published. So here's usually you have a publish button over here. When you click on publish, a publication URL, prediction URL will appear here. So if you want to unpublish, you can click on unpublish and it will just revert back. So I've already published it for you because it takes a little while. And I can click on prediction URL. It shows me certain prediction URL, like the API that I can use to finally export out my model. So I can create like a maybe a web app or simple website where I can use C# or any programming language. I can use this API. They can give detail on how it can be done, like what are the prediction key, what you wanted to set on, and so on. You can use that, create your model and create your website, which will use this API in the background. So you upload a new image of Dory. It sends the request to the server here in the which we have created, like the model on the server, and will give the result back on where the Dory, where the object is being located, and so on. You also have another option which is called export. So if I click on export, I have multiple options on how I can export the model. I can use it as Core ML on iOS or TensorFlow on Android. So if you know about TensorFlow, it's an open source library for creating various computation model. It's very popular library for computer vision, and one could simply export this model as tf.lite model and then write certain Python code on it or JS code on it, because TensorFlow also works with JavaScript. So TensorFlow.js code on it, and you can simply use these models. So you train it, export it, and use it for your end-to-end application. You have Windows ML, ML.NET, Azure IoT Edge, Azure Function, Azure ML, like a Docker file. You have Vision AI Development Kit, which is generally used if you are planning to make this on integrated like embedded systems like Raspberry Pi or Arduino or something. So you can use Vision AI Development Kit or OpenVINO. So it provides you different options on how you can export this model. If you, so for example, if I just click on TensorFlow.lite, it will ask me for what kind of TensorFlow model do I want? Do I want TensorFlow.js or Lite or Safe models? And I can simply click on export. So if I click on TensorFlow and click on export, it just takes a while to create a zip file, like saves all the prediction, all the like the performance of your model into one file, and it just saves it for you. So I think it got downloaded. No, it didn't download. So I click on download. Yeah, so it's downloading. It's just 9 MB. So the whole model with so many images, actually the images are not part of the export, but the information from those images have been exported into a compact 9 MB model, and you can simply use this to run your code. So these are the benefit of custom vision, because first thing, you didn't require a lot of data. You can simply train it in a very short amount of time. You can experiment with various possibilities, like various probability threshold and various training methods. And finally, you also have multiple options for export. And the final export that you have is just a small file. So so you can see on my screen, we have certain files here where we have a manifest file, which basically stores certain information, but your main model is the model.pb file. And in TensorFlow, you have option to simply import this and write code upon that. Like you can just wrap it with other stuff, or use it somewhere else, like with Azure Web Services. You can write a code and use these models. So you also have, if you want more details on it, you can simply log on to go to Microsoft Learn. Let's just figure that out. Microsoft Learn. Custom vision. So it will give you more information on how you can classify, like it has some modules on how you can use custom vision, and also have certain modules on how you can finally take it to to create end-to-end application with it, like analyze the model and create end-to-end application. So you have a lot of resources, you got how it works, you know about computer vision now. Now what remains is just getting onto it and starting working with it. I personally used this custom vision for a lot of my applications. Like I don't have those projects listed here on the screen, but I've used this before, and it did help. So I created during COVID, I tried this model. I had certain chest X-ray images, and I was just experimenting with how custom vision works. I created the model um, with certain chest X-rays to classify between the healthy lungs and the infected lungs. Although the model didn't say if it was infected due to COVID, but it could make that classification of healthy and infected lungs. And also, if you know about Power Platforms, if you know about Power Apps, you can actually also go to Power Apps. When you're creating app, it provides you an option to use custom vision. So it actually embeds the whole service of custom vision. So you can create a model and then include that model on Microsoft Power App and create an application, like a mobile application, which does this, which does computer vision, which does object detection, which does classification. So basically, you're also doing the first part, that is training the model, creating computer vision model with a no-code approach, and also doing Power Apps, which is a low-code approach. So both of them combined is a great resource with endless opportunities, endless possibilities, and you can do a lot of things. And it not only provides just custom vision service, but provides all the Azure AI service like Form Builder, where you can simply extract the text. For example, if you have form and you have certain field in the form like name, signature, date of birth, and so on, it can be even physically written form. What it is able to do is it is able to extract those information like the name and the date of birth and so on into a model, like a database, from those images. So it can do that, like, and many such opportunities, many such possibilities, endless possibilities. And when you can explore, put them together, create a lot of good applications out of it. So that's my time with customvision.ai and Microsoft AI Azure services. Maybe you can explore more, go through this Microsoft Learn uh, documentation and find how it works. Definitely experiment with it. It's really fun. I've already given the link for it was displayed in the slide for the Azure for the Dory images if you want to practice on the same data. And do let me know, like tweet about it, tag us Global AI, and also tag me and let us know what do you create with Microsoft Custom Vision Azure services. So amazing. Do we have any questions?
Hi, thank you a lot for the session.
I'm so relieved that we found Dory back, because
Yeah.
I was very worried before we started this session.
Yeah,
Yes.
Dory is my pet, and I love her so much. So glad that we found her back.
Yeah. You want to ask a question?
I don't have a question.
Oh.
I am also happy for this. It was fun. It was nice, and I like that the story was about Dory, because I also really like that girl. And yeah, I'm not sure I have anything to ask right now.
Okay. I don't have any questions as well, and we don't have questions from the audience. So it was a very clear story. That's what we can conclude out of it. I really liked your presentation.
Yes.
Thank you so much for joining
Thank you
us.
so much.
Yes, thank you
Thank you
so
for
much.
having me.
And we hope to see you again sometimes at our next event.
Definitely.
Next year?
Yeah.
Okay.
Awesome. Bye.
Have a great day.
Have a beautiful day.
Bye-bye.
Bye-bye.
You too. Bye.
So this is time to